Hello, grade 10 and 11. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Ah, So we have question 7. It says the diagram below shows a drinking glass with an inner diameter of 50 millimeter and a height h. Ignore the thickness of the glass. And then they say the volume of the glass is 250 centimeter cube. 7.1 says calculate the height h. And as we can see here, we are not given the formula for the volume of this shape here. So first we have to figure out that this shape here is a cylinder. And then to calculate the volume of a cylinder, we know that the formula is V is equals to pi r square h, right? So we are already given the volume. It's 250 centimeter cube. And then we have the diameter, but then we know the relationship of the diameter and the radius is that the radius is half the length of the diameter. So in order for us to find the radius, we'd have to say 50 divided by 2, which will give us 25 millimeter, right? But then here is another case. We are given our volume in centimeter cube, meaning that our length, or rather our dimensions, would have to be in centimeters. The radius here is in millimeters, so that means we'll have to convert this radius into centimeters. So this is where we get to the part whereby we need to know how to convert. So we have King Henry died a mysterious death called measles, and basically what you need to know here is the M here is for meters, the C here is for centimeters, and the M over here is for millimeters. So if you're going to that direction, you need to divide, and then if you're going to the right, then you need to multiply. So in a case whereby you have millimeters and then you're looking for centimeters, all you do is just put a 1 here and 0 on the desired SI unit, and then this tells you that you need to divide by what? By 10, right? So it is very crucial that you note those necessary conversions there. So if you want millimeters to go to centimeters, you need to divide by 10. But then again, if you want centimeters to go back to millimeters, then you'd have to multiply it by 10. If you want your centimeters in meters, then you'd have to divide by 100. But then if it's meters back to centimeters, then you'd have to multiply by 100. If it's millimeters being converted to meters, then it's divided by 1000. But then if it's meters to millimeters, then we understand that we have to multiply by 1000. So please note this, right? Know these necessary conversions by heart. Okay, so now let's then go back to the question. We have the radius now will be 25 divided by 10, which now the radius would have to be 2.5 centimeters. And then in order to calculate our height, we substitute in our volume, and then pi. Remember the pi, you can just punch it in your calculator, it's there. And then this is 2.5 square, and then h. This point we can just divide both sides by pi 2.5 square, and then both sides pi 2.5 square, right? Then this becomes h is equals to 250. If you are interested in having to calculate it there below and find what's your answer there, you can do just that, and then it will give you 19.63, which if you then punch it in your calculator, your value for h will be 12.736 centimeters, right? Okay, so this is your height, 3 marks. Now in 7.2, they say water is now poured into the glass until it is 65% full, right? So as we can see, this affects the height that will be filled by the water, right? So that means the height of the water is now only 65% of the height of the previous height that we calculated here. So this would have to be 65% of the height. So all the way from here until where the water stops, right? So, okay, we are now to calculate the total surface area covered by the water, which again, we are not shown the formula for the surface area of the cylinder. So surface area of cylinder is 2 pi r square plus 2 pi r h. But then another thing that you have to note, if you are given a cylinder and then your cylinder is not closed here, right? So it is hollow like that. So it is not closed. That means you do not have two circles. Remember, what you call a cylinder is made out of two circles, right? So this is why we have the 2 pi r squared 2. Actually, for the fact that we have a circle over here above and then we also have a circle below, right? But then if now we are saying the glass is open, just like this. Remember, it's a drinking glass, meaning that it is open here. So that means you only have one circular part, which is the part that is right here below, right? So that means you would have to edit the surface area of the glass as pi r square, then 2 pi rh. So always note that this is the surface area if you have an open cylinder, right? If you have an open cylinder, this will be the surface area of that cylinder. And then this one, if you have 2 pi r square plus 2 pi rh, that means you have a closed cylinder. So always note that the surface area for an open cylinder does not include the 2 here. The surface area for a closed cylinder does have the 2 over there. Then, okay, so this is pi. And then your radius, we did calculate, it's 2.5 square, then 2 pi. This is 2.5. But then for the h, we cannot substitute that one. We still need to figure out what is 65% of this. So we're going to say 65 over 100 multiplied by 12.736. And then we find that our height is actually equal to 8.034 centimeters. So you'd have to show this part as well. And then substitute it here, 8.034. And then at this point, you just need to punch all of this into your calculator, and then you get 70.11 centimeter square, right? Remember, it is the surface area, and the surface area is always unit square. Okay, and that's how you were supposed to tackle this question over here. Only 7.1 and 7.2. Okay, let's now proceed to the next question. We have question 7. It says, a concrete gate post comprises a right rectangular prism having a square base and a pyramid at the top, as shown in the diagram below. The length of the sides of the base is 30 centimeter and the height of the rectangular section is 150 centimeter. Then the perpendicular height of the pyramid section is 80 centimeter. Note that. Right. So now 7.1 says calculate the volume of concrete required to make one post. Right. So how are we going to calculate that? Now we do understand that the volume, this whole thing here is called a post, right? So that means in order to calculate the volume of a post, so for volume of post, we have to actually figure out that it is the volume of rectangular prism plus the volume of pyramid. So the volume of the post will be made up of the sum of the volume of the rectangular prism and the volume of the pyramid. Here we are only given the volume of the pyramid. We are not given the volume of the rectangular prism because also that's another formula that they expect you to know. So you never know which formulas you'll be given and which formulas you'll not be given. It is best to study all formulas. So this is length times breadth times height, and then plus the volume of the pyramid. We are told that it is 1/3. So it's 1/3 of the area of base times the height, right? So this will be what? Length times breadth times height. Our length is 30. So length base height 30 times 30 times the height is 150. And then plus 1 over 3. And then area of the base, remember this has a square base, right? So the area of the base will be for the for the square, we know that the area is just simply length times length, right? Or side times side. So this is just 30 multiplied by 30. And then we have to then multiply that by the perpendicular height, which is 8 centimeters. So there we go. And then obviously having to punch all of this into your calculator will have to give you 137,400 centimeter cube. Right. Okay, so now fine. 7.2 says calculate the surface area of the pyramid section of the post. The surface area. Again, we are given the surface area of the pyramid section. So we will have to say total surface area is equals to the area of the base plus half times the perimeter of base, and then times the slant height. Now, what is the slant height? The slant height will be obtained if you just come here, try to draw a 90-degree here. So this will be your perpendicular height. So suppose that your perpendicular height is 8 centimeter because it is equal to that one. Now, this line that you always draw here of the perpendicular line, you always draw it as a midpoint of this length here. So if it's a midpoint of this length, that means it bisects this length to 15 and 15. But then if you were to observe here, we now have a right angle triangle. And what we have here is what we call the slant height. So every time we are to calculate the slant height, you must always figure out that what we are actually calculating there is the hypotenuse of the right angle triangle, right? So that means for the slant height, we'll say it is simply 8 square plus 15 square. Where do I take the 15? From dividing the 30 there, bisecting the 30. And then now this will just become that. So S is for slant height. And then this will give us 17 centimeters. So just like that, we have the slant height. That means we can now calculate what is the area of the base. Remember, this is a square base, so our area is length times length. And then here we have half multiplied by the perimeter of the base, which is, it's going to be 4 times length times length, and then plus or times the slant height, meant to say. So multiply by the slant height. So let's now substitute length times length, that's 30 multiplied by 30, and then plus half times 4 multiplied by what? So remember, it's the perimeter, not the area. So let me fix here. So if it's the perimeter, it's 4 times L. 4 times L, right? Because what is the perimeter? Perimeter is simply adding all the sides. So this side plus that side plus this side plus this side. So one quick way to do it is just to realize that all the sides are equal in length. So you can just simply say 4 multiplied by 30. So that's 4 multiplied by 30 multiplied by the slant height of 17. So be careful by this. You do not put this height. You do not put the perpendicular height. You put the slant height when it comes to calculating the area. And then when you punch this into your calculator, that's 900. And then over here, you will get 1020. Then if you add them together, that's 1920 centimeter square. Again, it is the surface area. Okay, cool. Now, 7.3 says if the length of the sides of the base is halved, how many posts having the same design as the original can be made with the same volume of concrete as the original post? So we can see that this is a question on what we call the scale factors, right? So this is a question on scale factor. So that means what are they doing? What are they saying? They're saying they're halving the base of the sides. So instead of having 30, now we are having 15. So it's still the same shape. It's still the same shape, but then now only difference is now they have halved the bases. So now we have 15, we have 15, but then we still have 150 here. We still have our perpendicular height being 8 centimeters. Right. So now they're saying how many posts can we create if we just make a decision to halve the base? Then, okay, let's now find out. Remember, we do have the original volume, which is the old volume. So let's say V original, the original volume was 7.1. In 7.1, we did calculate that volume. We found that it was 137,400 centimeter cube. Now let's calculate the new volume. So again, we can still say 1/3. So we can still say, okay, first the one for the rectangle, it's length times breadth times height, and then plus 1/3 area of base, which is length times length, and then times the perpendicular height. Okay, so our length is now 15, and then our breadth is 15, our height still 150, and then plus 1/3 times length is now 15, and then 15 plus the perpendicular height is still 8 times. Why do I keep on saying plus? So multiplied by 8. Now when you punch all that into your calculator, you will get your new volume as 34,350 centimeter cube. Now if you want to compare it to that, so you will say, let's take the original volume, which is 137,400, divided by the new volume, which is 34,350. And then we find that it is 4. So the 4 means that we can make 4 posts from using the same volume. Using the same volume, we can make 4 posts. Okay, let's now proceed. We have question 6. It says the cylinder in the diagram below has a diameter of 4x units and a height of h meters. The cylinder is open at the top. Note that. The cylinder is what? Open at the top. And the total surface area of the cylinder is 32 pi meters. Calculate height h of the cylinder in terms of x. So that means here we are not trying to calculate the value of h, but then we are just trying to express h in terms of x, right? So we're not going to get a numerical value here. So first, let's figure this out. Open at the top, meaning that our surface area will now be what? Pi r square plus 2 pi rh. So remember, if it's open at the top, we don't have the 2 here. And then our surface area, it's 32 pi. We are told here the surface area, the total surface area of the cylinder is 32 pi. And then this is just pi. Remember, how do we now find the radius? We are given the diameter. The diameter is 4x, but we know that the radius is simply the diameter divided by 2. So that's 4x divided by 2, which will give us 2x. So where there is radius, I will put 2x and then square that here. And this is 2 pi. Where there's radius, I need to put 2x. And then this is my h. So basically, I want to make h the subject of the formula. So that's 32 pi. Here, this is 2 square is 4. And then this is 4 pi x squared. And then right here, we'll have 4 pi x h. And then we can take this, transpose it over to that side. 32 pi minus 4 pi x squared. Remember, we are trying to isolate h. So again, we are not done isolating h. If we want to only remain with h, that means I have to divide both sides by 4 pi x. If in here 4 pi x, and then that means my h is now what? I can now write this as 32 pi over 4 pi x minus 4 pi x squared over 4 pi x, right? Remember, if you have something like this, you can express each and every term to the same denominator here. Now, what is 32 divided by 4? That's 8. The pi and the pi will cancel out, so we'll be left with the x on the denominator. Here, the 4 and the 4 will divide out. Pi and pi will divide out. From the x squared here, we'll cancel out 1x, so we'll be left with the x on the numerator. So this is our expression for h. You leave it like this. From this point, you cannot go further. So that's your final answer like that. You have expressed h in terms of x. So that's all you needed to do. Okay, then now let's proceed to the next question. It says a foul run is designed in the shape of a cone. A hemispherical bowl of water is placed close by for the chickens to drink from it. The cone and the hemisphere are drawn as shown below. Then we are given the total surface area of the cone is pi x squared plus pi rs, where s is the slant height of the cone. The total surface area of the hemisphere is 3 pi r squared. The radius of both the cone and the hemisphere is given as x units. So very important statement there. The radius of both the cone and the hemisphere is given as x units, as we can see here. And it is further given that the total surface area of the cone is equal to the total surface area of the hemisphere. Find an expression for h, the height of the cone, in terms of x. Again here, we are trying to find h in terms of x. So what are we going to do? We are going to use the fact that the total surface area of the cone is equal to the total surface area of the hemisphere, meaning I can now equate these two expressions. So that's I will say volume of cone equal to volume of hemisphere. So meaning volume of cone is pi r square plus pi rs is equals to 3 pi r square. But then remember, they said that your r is x, right? Your radius is equals to x. So that means where there is r, I can just substitute by x. So this will be x squared. This will be pi x, and then slant height is equals to 3 pi x squared. Now that means I can take this and transpose it over there. And then this will be 3 pi x squared minus pi x squared, which these are like terms, so I can just say 3 minus 1. So this will be pi x s, and then this is 2 pi x squared. In order to isolate the slant height, I would have to say pi x divided by pi x. Then my slant height would have to come out as a pi divided by pi, 1 of the x divided by 1 of the x here. So I'll be left with 2x. So my slant height now would have to be represented by 2x. So that means I can come here and say my slant height is equals to 2x. Therefore, let me have 2x here. But then if you can have a look at this, now we have a right angle triangle. And then you can agree that we can express our h in terms of x by simply just using Pythagoras theorem here, because we have a right angle triangle. So our Pythagoras theorem says we'd have the slant height square, and then we'd have our radius square, and then we'd also have our height square. Now our slant height is 2x, and then square that. Our radius is just x, then square that. Our height is just height. Remember, that's the one we are trying to make the subject of the formula. This will give us 4x squared. Let's transpose this over. It will be minus x squared, and then is equals to h squared. 4x squared minus x squared gives us 3x squared. And then to calculate h, we need to square both sides like this. And then therefore, our h will become what? Root 3 and then x. So that's it. It's root 3x. Remember, the x squared here, the 2 will cancel out, so the x comes out of the square root, but then the 3 cannot leave the square root there because if you just say root 3, it remains as root 3. Okay, and then that's all you needed to do there. Awesome. So again here, we did not find the numerical value of h. We only expressed it in terms of x. Okay, then let's proceed. We have this question here. It says calculate the length AH. So 7.1, we are given the roof of a canvas tent is in the shape of a right pyramid having a perpendicular height of 0.8 meters on a square base. The length of one side of the base is 3 meters. So it's on a what? It's on a square base. This is very, very important, right? So it's on a square base. As you can see here, we are not given even one formula. So meaning everything that you have to calculate here, you have to be sure about the formula. Then 7.1.1 says calculate the length AH. This is the AH. And then as we can see, the AH is actually the slant height, right? So we can see that right angle triangle being drawn there. So this height that you are seeing here is the perpendicular height. It is similar to this height here. So if in here it's 0.8, I know it might look a bit off as if this height can't be the same as that height. But then it is actually the slant height over there. So the height that you are seeing from point G all the way to A is the very same height here. So in 3D, it might look a bit confusing, but then if you can just do like this, you would see that actually this lies on the same plane, right? So this is our perpendicular height like that. So that means in order to solve this, I need to actually say AH is equals to 0.8 square. But then again here, when we are considering this length here, we need to always remind ourselves that this length here is always half the length of the base. So the length of the base here is 3, and then this one is always half the length of the base, which means it has to be 1.5. So it's 0.8 square plus 1.5 square, and then that's AH square. And then now if you say AH square and then you add those ones, then they're supposed to give you what? So punch it in your calculator. You are supposed to get 2.89. And then obviously when you now have to square both sides, your length for AH becomes 1.7 meters. Okay, so that's it. Now you have your slant height. 7.1.2 is now saying calculate the surface area of the roof. So we know that the surface area needs us to have that slant height. So that means we have to now use that slant height. So again, what is the surface area? The roof, remember, they said the roof is the pyramid, right? So surface area is area of base plus 1/2 times the perimeter of base. So I'll say P of base times the slant height. So that's the formula that we have. Okay, then in this case, we'll say the area of the base is what? So remember, the base that we have is this one here. But then if you can come to think about it, if we are putting a tent over here, we know that this part here does not exist. We know that this part here, if we are putting a tent, remember, a tent just goes over like this and then covers the sides, right? So a tent just goes over like that to the roof and covers the side. So that means this one here, the surface area, the total surface area, also includes the area of the base. But then since the tent does not have some kind of a roof here that goes like that here, then that means we cannot consider the area of the base. Meaning, in other words, our surface area here would only need to be represented by 1/2 times the perimeter of the base and then multiply that by the slant height. So this will become 1 over 2 multiplied by the perimeter of the base is what? Remember, this lies on a what? On a square base. So if it lies on a square base, what would be the perimeter of that base? Remember, all these lengths are 3, 3, 3. So that means I would have to say 4 multiplied by 3. But then what is my slant height? I did calculate it's 1.7. So when you punch all that into your calculator, you get 10.2 meter square. Right. So it is very, very crucial that you understand how removing some of the parts here actually affects your formulas for the surface area. Okay, then 7.1.3, they are now saying if the height of the walls of the tent is 2.1 meters, calculate the total amount of canvas required to make the tent if the floor is excluded. Once again, we know that the tent will only go over the sides and then over there to the roof, right? But then you never see a tent that has a roof, that has a floor there. So that means in this case, we need to consider this. The area that we'll be considering here is only the area of these sides here. So let me lay it down to you. So that means if you are to check here, we would only be considering the area of this side and then also the area of the front side here. So this is the second rectangle. And then also consider the area of the back side. And then lastly, the area of this one over here. So in total, how many rectangles do I have to consider the areas for? Only 4. Remember, this one I cannot include because this speaks to the floor. This speaks to the roof, and then we don't have anything closing here on the tent, right? Because a tent is just hollow here, and then the roof only is this part. Okay, so now if we are to calculate the surface area of the rectangle or of the rectangles, then it would simply be 4 multiplied by length times base. Because we have 4 rectangles. Remember, the height is 2.1 meters, and then the base is 3 meters. This is how I know it's a rectangle, because these dimensions are not equal. So this is 4 multiplied by length, let's say it's 3, and then breadth, let's say it's 2.1. And then when you punch all that into your calculator, you get 25.2 meter square. But then remember, we are to calculate the total surface area of the canvas that is required. So that means for total surface area, we then have to say it's the 25.2 meter square plus the area of the roof, because the tent is the sides here covered and also that roof. So the area of the roof we had calculated above, it's 10.2 meters square. And then when you add the 2, you are going to get the total surface area of 35.4 meter square. Okay, that's how you were supposed to solve that question. Then 7.2 says a metal ball has a radius of 8 millimeters. Calculate the volume of metal used to make this ball correct to 2 decimal places, the volume, right? Now, you'd have to know what is the volume of a what? Of a sphere. Remember, a ball is in the shape of a sphere, right? So again, you are not given the formulas. So 7.2.1, you'd have to say, okay, the volume of the sphere is 4 over 3 pi r cube, right? So make sure that you study the formulas. Then that's 4 over 3 pi. They said the radius is 8 milliliters. So we're just going to substitute in the 8 there. Then when we punch it into our calculator, we get 2,000 144.66 millimeter cube. Right. Nice one. Then 7.2.2, it's saying if the radius of the ball is doubled, right? If the radius of the ball is doubled, write down the ratio of the new volume to the original volume. Okay, so now if we are doubling the radius, let's now calculate what would be the new volume. So this is 4 over 3 pi r cube. And then we do understand that this will now be 4 over 3 pi. And then we are doubling the radius. So that means instead of 8, we have 16. And then you simply punch all that into your calculator. So you will have your 4 over 3 and then pi. And then you have 16 cube. So this will give us 17,157.28 millimeter cube. Now, if we want the ratio of the new volume to the original volume, so we'll say new volume is 17,157.28, and then original volume is 2144.66. Now, if we want the ratio, let's divide by the smallest number both sides. So the simplest ratio, you will divide by the smallest number both sides. And then this here is giving us 8, and then obviously this is 1. So the ratio of the new volume to the original volume is 8:1, which is telling us that the new volume is 8 times the original volume. Okay, so and that's it. That's your 7.2.2. And then 7.2.3, it's saying you would like this ball to be silver-plated to a thickness of 1 millimeter. What is the volume of the silver required? Give your answer correct to 2 decimal places. Right, so this is what you're supposed to do now. You would like your ball to be silver-plated to a thickness of 1 millimeter. So let's say this was your ball initially. It was not plated. So original. And then now, this is how you would like your ball to be, silver-plated. Remember, if you plate the ball, you are actually increasing to the diameter and radius of the ball. Right, so that means this one had a radius of 8 millimeters. Now, if you are plating this to a thickness of 1 millimeter, meaning the radius will now be from this circumference all the way to the center, it's now going to be 9 millimeter, because now there's the 1 millimeter thickness here of the covering of silver. So that means the new volume now, 7.2.3, the new volume would have to be 4 over 3 pi r cube, and then this is 4 over 3 pi. The radius is now 9 instead of 8, because now it has the extra 1 millimeter thickness there. And then if you calculate that new volume there, it's going to give you 3,053.63 millimeter cube. But if we want the volume of the silver that was used to plate the metal ball, then this is what we need to do. We need to take this old volume or this original volume and then subtract it from the new volume. And then the difference between the new volume and the original volume will have to be the volume of the plating, right? Or the volume of the silver that was used to plate the metal ball. So that means volume of silver would have to be the volume new minus the volume original. So the new volume is 3,053.63, and then the original volume is the one that we calculated in 7.2.1, which was 2,144.66. Now, when we subtract that, we are getting 908.97 millimeter cube. So this means this is the volume of silver that was used to plate the metal ball. Okay, that's how you were supposed to go about answering that one. Let us proceed to the next question. Okay, we have this one right here. We are just given a bunch of formulas here, which we are not told it's for what. So volume is equals to 1/3 area of base times height, and then A is equals to length times breadth. So you were just given formulas here. That means it was up to you to know which formula applies to which instance. Then this is our question 4. It says the right pyramid has a square base of side 80 centimeter and a height of 90 centimeter. Right, so a square base. Again here it's a what? A square base. Then 4.1, determine the length of the slant height. How do we determine the length of the slant height? We already know the slant height is your hypotenuse. So you use your Pythagoras theorem there. Okay, so this is what we can do. The slant height is this. We have our perpendicular height like this. And then if we can just close off here so that we form that right angle triangle, then we do understand that this height that we are having here, this height that we are having, or even if we do it like this, let's do it from this part here. Now note that this length here is also 80 centimeter, but the length that we have here is actually half, right? So this perpendicular height, when it's drawn to bisect, right? It is always drawn to bisect this line here. So meaning that we have 40 centimeter here and then also 40 centimeter here. Looking at this, we can see that we have formed a right angle triangle, and then our slant height here becomes that, right? So that becomes our slant height. So even if in this case here, we try to look at it from this angle here. So that's even here, that's the 40. And then our slant height, we can see it. So it's a bit tricky if you have to like view it in 3D eyes, right? So, but then you have to always understand that the length that you have here as your base will be half, will be half the length of the square base here. So that means if we can just consider here, this is 40 centimeter, this is 90 centimeter, and the slant height that we are looking for is this. So it's a bit confusing. And then 4.1, we are going to say the slant height is equals to 40 square plus the perpendicular height, it's 90 square. Then when you punch all that into your calculator, remember you need to then just put it in the square root. And then this is going to be 10 root 97. And then centimeters. So let me remove this. It's not S squared, it's just S. Okay, there we go. Then the slant height is 10 root 97 centimeters. So that's it for 3 marks. That's it for 3 marks. 4.2 says, calculate the volume of the pyramid. Now, if you can check here, this is the volume of the pyramid. This is the formula for the volume of pyramid. So we'll say V is equals to 1/3 times area of base times the height. Now the area of the base we are told that it is a square base. So this will become length multiplied by length and then times your perpendicular height. Okay, so this point we are going to say 1/3 multiplied by 80, remember the square base, we multiply the length of the square, times the perpendicular height is 90. We are not using the slant height on volume. So the slant height is only used on the surface area. For volume, you use the perpendicular height. And then when you punch that into a calculator, you get 192,000 meter cube. Right, that's it. And then for 4.3 now, they're saying, calculate the total surface area of the pyramid. Now, if you were to check here, there is not even one formula for the surface area of the pyramid. So what you have here, this is the area of I think it's the area of the hemisphere, if it is not the sphere. So sphere or hemisphere. And then this one here would have to be the one for the cone, right? Okay, so what you need to check here is to find the total surface area of the pyramid. We know the formula. We'll say TSA is equals to, this is always area of a base times 1 over 2 perimeter of base times the slant height. So this is the total surface area of the pyramid, which as we can see here, it is not given. You needed to know it. Then what is the area of the base? Area of the base, again, will be length multiplied by length. Then we have plus, this is supposed to be plus, not times. So plus half perimeter of the base. Perimeter of the base will be 4 multiplied by the length because the base is a square. So if we are to consider the perimeter of a square, we do understand that this is 80, this is 80, 80, and then 80. So the perimeter is just adding all the sides here, which we can simply get it by saying there are 4 sides and then multiplied by the length, since all the lengths are of equal size. Then multiply that by the slant height. Now the length is 80, so we are going to say 80 times 80 plus half and then 4 times the length, 80, then multiply that by the slant height. The slant height is the one that we calculated in 4.1, which gave us 10 root 97. And then now you simply punch all that into your calculator. You get 22,158.17 centimeter square, right? Correct SI unit. Okay, and that's how you were supposed to calculate that. So it is very crucial again that you know your formulas and then you don't confuse your formulas. Because you see, with a question like this, whereby they just give you random formulas and then they don't tell you this one is for which one, then you might find yourself making a mistake and just picking any other formula because you are desperate. And then let's proceed. We have the last question here. It says the diagram below shows a sphere with a diameter of 30 centimeter placed inside an empty cylindrical tank of radius 45 centimeter and height 80 centimeter. So we are told that the sphere has a diameter of what? 30 centimeter, right? And then the cylinder is then filled with water. Then 6.1.1 says calculate the volume of the metal sphere indicated in the diagram as A, right? The volume of what? The metal sphere. So we are given the formulas here and then we are told this is the volume of the sphere. So that means straightforward, we just say V is equals to 4 over 3 pi r cube, right? Not square, cube. And then this is 4 over 3 and then pi. Remember, we are given the diameter. Diameter is 30, but then we know radius is half of the diameter, so it's 30 divided by 2, which means there we have to put 15. So this is 15 and then cube that. So if you punch all that into your calculator, you are getting 14,137.17 centimeter cube. Right, so for 2 marks, that's all you needed to do. Then say 6.1.2 says calculate the volume of water required to fill the tank. Now, this is a very interesting question. Remember, the water must be filled into this glass, right? So how many shapes do we have here? We have a cylinder, which is, again, it's open, right? So the cylinder is filled with water. This is a drinking glass. So that means here it is open. Right, we know what it does to the surface area of or of the cylinder, but then here we are not on that one. We are actually on volume, so the volume is unaffected. So, okay, if we want the volume, the capacity of the glass, right? We want the volume of the water that will be filled into the glass, then you can agree that I can calculate the volume of the cylinder and then subtract the volume of the sphere. Now, if I take the volume of the cylinder minus the volume of the sphere, then what I'm left with is the volume of the water that will be filled in the tank, right? So, oh, it's not a glass, it's actually a tank. Dang. Then this is V is equals to pi r square h for the cylinder, then pi. Our radius, it's 45 for the cylinder, so 45 square. And then our height is 80. Then when you punch all that into your calculator, let's check. We have pi 45 square multiplied by 80. And then this is giving us 508,938.0099. SI unit, it's centimeter cube. And then now, because I already have the volume of the sphere, I will say to calculate the volume of water, then it is simply this volume here of the cylinder. So volume of cylinder tank minus the volume of the sphere. And then this is 508,938.0099 minus the 14,137.17. Then when you subtract those, you get 498,800.84 centimeter cube. Okay, and that's how you were supposed to solve that one. Okay, so now they're saying the sphere is removed from the tank as seen in the diagram below. Calculate h, the height of the water remaining in the tank. So they now want h. Remember, if we remove the sphere here, we do understand that the water, remember, the water maybe was filling all the way to the brink. But once we remove the sphere here, we understand that the height of the water would have to decrease. Now they want us to calculate the height, but then us removing this sphere here does not affect the volume of the water, because remember the sphere does not contain water, right? So we are only taking out the sphere, and then the volume of water will still remain the same. So that means we'll still have to use the same value that we got from 6.1.2 to calculate 6.1.3. So we are going to say calculate h, height of the water remaining in the tank. So that means the tank is a cylinder, right? So V is equals to pi r square h. And then the volume, we are still using the same one that we got, which is 498,800.84 is equals to pi. Our radius is still the 45, and then square, and then h. Then we can divide both sides by pi 45 square, and then even here pi 45 square. Then you simply just have to grab your calculator and punch all of this into your calculator, and then now you will get a value of 78.41 centimeter. Right, that's it. Then we have 6.2. It says the sphere is then melted down. The sphere is then melted down into a solid cone of height 25 centimeter. Calculate the radius of the cone. So they say the sphere is melted down, meaning that if we take the sphere and melt it down, the volume of the sphere does not change, right? Remember, we are taking the same sphere and then we are making it into a cone. We are not changing the capacity of that particular object, right? So, or that particular figure. So the sphere would still possess the same volume, the cone will still possess the same volume as the sphere. And then that means, in other words, the volume of sphere here is equals to the volume of cone. But then now, once they make it into a cone, it now has a height of what? 25 centimeter. So that means I have to use this formula now. Volume of cone. So volume of cone is 1/3 pi r squared h. Now the volume is still the one that I got in 6.1.1, which was 14,137.17. Remember, it is the volume of the sphere. Then 1/3 pi, we are looking for what? The radius. So I'll just leave it as r squared. And then the height, we are told that it is 25. So at this point, what must I do? Can start dividing both sides by this 25 here. Like that. So it's going to be 14,137.17 divided by 25, which will give me 565.4868 is equals to 1/3 pi r squared. And then in order to get rid of this 3, I can now multiply both sides by 3, right? Multiplying by the reciprocal of this number. So if I multiply that by 3, then I'm left with pi r squared is equals to what? 1,696,4604. And then now I can divide by pi. And then this is r squared is equals to square root 1,696,4604 over pi. And then now let's put all that into a square root. So my radius now will become what? So if I punch that into my calculator, my radius becomes 23.24. And then meters, centimeters, rounded off to 2 decimal places. Okay. So that's how you were just supposed to do your math right there. So that's your maths right there. So this is 1/3. Okay, nice. And that's how you were supposed to tackle all of these questions. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.